So, you are welcome to the course Experimental Physics 2. I am Amol Kumar Das from Department of Physics, IIT Kharagpur. So, in this lecture I will give introduction about this course. So, what is the aim? So, what are the concepts will be covered in this lecture? So, I will discuss about the aim of this course, then syllabus of the course, as well as about the laboratory and the apparatus. So, next let us discuss about the aim of this course. So, the experimental physics course is designed in 3 modules. Each module is of 30 hours. So, what are those 3 modules? The experimental physics 1, where experiments on mechanics, general properties of matter, thermal properties of matter, sound, electricity and magnetism are discussed. In module 2, experimental physics 2, so we will discuss about the experiments on optics and quantum physics, and third module experimental physics 3, we will discuss experiments on solid state physics and modern optics. So, this experimental physics 1 was offered in last semester and nearly 2500 students have taken this course. In this semester, the experimental physics 2 will be offered. The experimental physics 3 may be offered in successive semester. So, like experimental physics 1, who has taken this course, you know that this so there we have mainly discussed these experiments in very simple way, and this course was suitable for science student, engineering as well as technology student. So, like this experimental physics 1, this module 2 is also suitable for all undergraduate students of science, engineering and technology. There is no prerequisite for this course. Science background in class 2 level is enough to understand this course. This course is self explanatory and will make you understand the working principle of many common devices through their applications in different experiments with particular aims. This course is basically compulsory for all students who are pursuing for degree in BSc, BE, BTech, including the integrated MSc, ME and MTech, apart from the development of skills for the profession where instruments are to be handled. Okay. So, also this course will have positive feedback for national level examinations like GATE, NET, JAM and JEST conducted by IIT, UGCSR, IIT and ACRB respectively. In this module 2, you will learn about the reflection, refraction, interference, diffraction, polarization and quantum physics through different experiments. So, syllabus of this course are the following. So, I will discuss about the basic analysis in the laboratory. So, basically I will discuss significant figure, source of error in the measurement, minimization of errors in the measurement, importance of calibration, importance of data plotting in graph papers, interpretation of results as well as precautions in the laboratory. Also, I will discuss about the basic components in the laboratory. So, for required for this course. So, basically I will discuss about the light source, that is the compulsory for optics experiment, and then I will discuss about the mirror, lens, prism, grating, beam splitter, polarizer, XYZ translator, rotation or tilt stage, spirit level, spectrometer, telescope, microscope. So, these are the basic instruments, tools in the optics lab. So, as I told, light source is compulsory for optics experiment, as well as you will see mirror, different kind of mirror. One is plane mirror. So, mainly it is used for changing the direction of the light, and there are other mirrors, this convex mirror, concave mirror. Also this lens, it is also two types, this convex lens, concave lens, again this plano-concave, plano-convex, etc. Okay. So, I will discuss about this and their principles, their properties, and where we will use them. So, I will discuss, and then another important component is prism. So, this prism itself, using prism you can do experiment how to measure the angle of the prism, and this prism is used for dispersion of light. So, prism will be used for dispersion of light. So, it has dispersive power, and also prism is used to align the spectrometer, means to make ready the spectrometer for parallel rays. How to use this prism for getting parallel rays for the experiment that we will discuss. And you know, grating is very important tools, very important components to use as a dispersion of light, means to separate the wavelength of the light. So, this grating is used. Also, grating is used to measure the wavelength of the unknown light. So, this we will discuss about the grating. Then beam splitter. So, from same source of light we can, so one ray will come, and this ray we can split into two or more using the beam splitter. And polarizers, this is another tools which is used to polarize the light, and to analyze the polarization of the light, we use also this, that is called analyzer. That is nothing but the same tools. It can be used as a polarizer, it can be used as a analyzer. So, depending on the use of we call this same tools as a polarizer and analyzer. Also, in optics experiment, this you need to align the light, align the path of the light. Okay. So, for that you need to translate the components, it can be mirror or lens or whatever. So, we use different kind of stage which have option that you can move your component along the x direction, along the y direction, along the z direction. So, such type of stage is frequently used in optics experiment, and also you need stage for rotation of the components, okay, as well as tilting of the components. So, so that type of stage also very essential and very and frequently used in optics experiment. And spirit level, of course, it is used to leveling the spectrometer, and spectrometer itself is very important for this optics experiment. So, we will discuss about the spectrometers, what is the construction of the spectrometer, what are the components are there in the spectrometer, and what are the purpose of different components in the spectrometer. Also this telescope microscope, that also very important component for optics experiment, and also it has general use. So, we will discuss about this telescope as well as microscope, what are the construction of these two components. So, then we will demonstrate different experiments on optics. So, one experiment, this here I have given number 1 experiments. So, determination of refractive index of water. So, how to determine the refractive index of water, that we will demonstrate in the laboratory, in our laboratory. First I will discuss about the principle of this experiment, and then I will show the experimental setup for this experiment, and then how to perform the experiment, how to analyze the data, and how to get the result. In this case, result is the refractive index of water. Then we will discuss about the determination of focal length of a convex lens, focal length of a concave lens, and then we will demonstrate about the Schuster's method. This is very important method in optics. In optics laboratory, this method is very important, and what is the importance of this method? So, that I will discuss when I will demonstrate about the Schuster's method for focusing a spectrometer for parallel rays. So, in many experiment you need parallel rays from source, that rays are coming, they are not parallel. So, but for experiment I need parallel rays. So, how to get parallel rays? So, that basically one can get using this Schuster's method. So, that method I will demonstrate. Then we will demonstrate how to determine the angle of a given prism. If one prism is given to you, so how to find out the angle of this prism. Then we will discuss how to find out the refractive index of the metal of the prism and its dispersive power. Then we will demonstrate how to determine the refractive index of quartz prism, okay, for ordinary and extraordinary rays. So, what is ordinary, what is extraordinary rays, how it is formed, and for ordinary and extraordinary light, this the same prism, but refractive index will be different for these two type of rays. So, that will demonstrate how to determine the refractive index for O ray, and O ray means ordinary ray and E ray means extraordinary rays. Then we will study the formation of Newton's ring in the air film in between a plano convex lens and a glass plate using nearly monochromatic light from a sodium source, and determine the radius of curvature of the plano convex lens. So, here 7 to 13 that experiment here I am showing. So, that experiment is basically the experiments of interference. So, here basically you will learn that about the interference, and from using the interference how we can use to determine the wavelength of say sodium light using the Fresnel's biprism, or using the Fresnel's mirror, or using the Lloyd's mirror. So, these all this experiments is based on interference of the light. So, then these two interferometers are very important, this Michelson interferometer and Fabry-Perot interferometer. We will discuss about these two interferometer and how these interferometer are used for the determination of wavelength of light. So, that we will demonstrate in our laboratory. So, then here I think this 14 to 17. So, these 4 experiments are based on diffraction of light. So, we will demonstrate this experiment. So, this 14th experiment here basically demonstration of Fresnel diffraction due to circular aperture. So, two types of diffractions are there. So, one is Fresnel diffraction, another is Fraunhofer diffraction. So, I will discuss about Fresnel and Fraunhofer diffraction before doing experiment. So, this will demonstrate the Fresnel diffraction due to circular aperture. So, Fresnel diffraction can be seen for other type of source. It may be sharp straight edge, it may be circular aperture, etc., etc. So, next we will demonstrate the effect of width of a single slit. So, basically that is that diffraction experiment for single slit, for double slit, for multi slits, n number of slits. So, that is basically getting. So, we will demonstrate this all three experiment based on these different types of slits, and we will discuss how to determine the wavelength from this experiment, or how to determine the grating element or spacing of the slit and width of the slit. So, that or the effect of the width of the slit. So, that all things we will discuss in these 3 experiment. Then this last 3 experiments in optics is basically on polarization of light. So, we will study the polarization of light by reflection, and we will verify the Brester's law and Malus law. Okay. So, what is Brester's law, what is Malus law? So, that we will discuss and we will verify this law. Okay. And yes, so that will be verified by the polarization of light by reflection, and then next experiment will demonstrate the linearly, circularly and elliptically polarized light using the wave plates and polarizers. Wave plates, so there are different kind of wave plates. So, this quarter wave plate, half wave plate, full wave plate. So, that we will discuss during the experiment, and then last experiment will discuss, will demonstrate. So, how to determine the specific rotation of a substance. So, in our case we will take sugar. Okay. So, we can find out, we can determine the specific rotation of sugar using an instrument that is called polarimeter. So, next we will discuss, we will demonstrate few experiments on quantum physics. Okay. So, basically before starting rigorous quantum mechanics, so some preliminary modern physics started to come. So, that basically we tell the quantum physics, right. So, basically quantization, quanta. Okay. So, that concept when started to nucleate. So, that started basically from the basically Planck's after discovery of the Planck constant H, okay, and then photoelectric effect, then this Bohr theory of atom. So, in atom how the electrons are arranged. So, that was the preliminary stage of quantum mechanics. So, that time there was a, so in science you have to prove all the model, all the speculation. So, there are very important experiments that time are used to verify the models, to verify the speculation. So, we will discuss some of them. So, this we will discuss about the demonstration of Frank-Hertz experiment to prove the existence of discrete energy levels in atoms. This is very nice experiment. So, that we will discuss, we will demonstrate in our laboratory. Then we will show how to measure the wavelength of emission lines of hydrogen atoms, basically Balmer series, and how to calculate the Rydberg constant. So, you know this Rydberg constant in case of this explanation, in case of explanation of the atomic spectra. Basically, it's the started from Balmer series. So, we will demonstrate in laboratory how to measure the wavelength of hydrogen atom. So next we will demonstrate how to measure the electric charge of a single electron by that experiment, famous experiment that is called basically Millikan's Weyl-Dropf experiment. So, we will demonstrate this experiment in the laboratory. Then we will discuss another experiment, how to find out the Avogadro number. This is again another important fundamental constant, Avogadro number, using voltmeter, silver voltmeter. Then we will discuss how to measure, how to find out the E by m of an electron, okay, electron charge and electron mass, ratio of electron charge and mass, how to find out this ratio using a method that is called helical method. Then we will study the photoelectric effect to demonstrate the discrete nature of light. Okay. So, that is the effect that is the effect where which was discussed, which was explained only considering the discreteness of the light. Okay. So, that is called basically photons. So, actually this light have wave property as well as particle property, particle nature. So, this particle nature that we tell, that is photons. So, that we will demonstrate in laboratory. Then we will determine the Planck's constant, which is a very fundamental constant, universal constant, and that was basically it has importance in quantum mechanics. So, how to find out the Planck constant, that also we will demonstrate in our laboratory. Okay. So, here I thought of demonstrating almost 27 experiments, but I will see if time permits, I will discuss all experiments. The demonstration may not be in sequence, but I will try to discuss all of them. So, yeah, I think I will stop here. So, thank you for your kind attention.